Hi, I'm Arindam Kumar, Mathematical Mind Online Classes. Today we are going to start what asymptote. Do you know about the asymptote? So, asymptote is two types, right? Uh, asymptote, asymptote. You know the asymptote is two types: vertical asymptote, vertical asymptote, and horizontal asymptote. Two types of asymptote: vertical asymptote and horizontal asymptote, right? So first of all we introduce about vertical asymptote. Vertical asymptote. Okay, vertical asymptote is defined: a vertical asymptote is a line x is equals to c, that the graph approaches to as y value goes to goes to positive or negative infinity, right? So this is the vertical asymptote, and vertical asymptote is a line which is can doesn't touch on the graph. Like if I draw the graph of vertical asymptote, look like this: y, x dash, y, and y dash. Let's see here. Here x is equals to c, right? Then you dot graph. That means the graph is never touch this line. Okay, this graph is never touch the line. So the graph is draw here look like this, and this graph is versus look like this. But never the graph is never touch on the line, dotted line, right? So this is the graph. Now the the how can find the vertical and horizontal asymptote. So what is the rule of how can find uh, the vertical asymptote and horizontal asymptote uh, of the given function? So what is the rule is there? So rule of vertical asymptote. Rule of vertical asymptote. Rule of vertical asymptote. So for a rational number, for a rational number fx is equals to px over qx, right? So this is the rational number, and you know very well about we have to find the vertical or either vertical or horizontal asymptote depend on the rational function. Okay, so the first of all we have defined the rational function and then follow the rule. So here first is simplify the function by factoring and cancelling any common terms. Second is the denominator set the denominator equal to 0. Third rule is says solve for x. These values are called vertical asymptote. Okay, vertical asymptote. So here I shall give you first example. Example fx is defined. This is the rational function x plus 2 over x square minus 9. So first is rule says simplify and factoring. So there is a not simplify because this is the co-prime x plus 2 and x square minus 1. There is no common factor of numerator and denominator. So this is so first of set the denominator. Second rule follow. Second rule is says factoring x square minus 9 is equals to 0. Now if you say x square adding both side 9, then here put 9 is equals to 0 plus 9. So here x square is equals to 9, therefore x is equals to plus minus root over 9 is equals to plus minus 3. Okay, so there are the uh, two factors, two asymptote are given, either x is equals to 3 or x is equals to minus 3. There is a two asymptote of the given function. Now we have introduced about how can plot the graph. I some discussed with you another example how can find the vertical asymptote look like this. So if I draw 3 over x minus 4, right? So there first of all with the denominator set the denominator equals to 0, rule 2. So x minus 4 is equals to 0. This implies adding both side adding both sides x minus 4 plus 4 is equals to 0 plus 4. This implies x is equals to 4. So here how can draw the graph, how can find the graph. Okay, so this is first of all we draw graph x y coordinate y and y dash. Now here 1 2 3 and goes to 4. So you plot the vertically dotted line parallel to the y-axis, and the graph intersect. The graph is plotting look like this. The graph is plotting. Say x doesn't touch the graph, right? So the graph this one extended. So look like this, and here the graph is extended look like this. This is the graph of vertical asymptote, right? So and domain of function rational function is 3 over x minus 4. So all all real number except x is equals to 4. This is the graph. This is the domain of all real number. Domain of fx is is all real number except x is equals to 4. Now I give you another example. Explain So first F5, another example is 5x plus 3 over 3x minus 7. So asymptote is equals to asymptote. How can find the asymptote? So 3x minus 7 is equals to 0. This implies adding both side, adding both side. Look it here, adding both sides. 3x minus 7 plus 7 is equals to 0 plus 7. So this implies here 3x is equals to 7. Therefore, x is equals to 7 over 3. Now, the domain of function fx is equals to 5x plus 3 over 3x minus 7 is all real number all real numbers except 3x7 over x is equals to 7 over 3. This is the graph. Now, this how can plot this type of graph? Okay, so here is 2.2.3, right? So we have to draw the graph. Look here. So graph is -1, -2, -3, 1 and 2. Here is 3. So this is the partition of this graph vertically. Look like this. This is the y dash and here y, x and here x dash. So this is the asymptote at x is equals to 7 over 3, 2 point something, look like 2.3. So the graph which is passes from the look like this. So if I draw same thing, here is look like this, and the right side the graph is plotting look like this. This is the graph of here 5x plus 3 over 3x minus 7. Okay, this is the graph. Now I have discussed uh, this is the examples and question rules are the vertical asymptote, right? We have introduced horizontal asymptote, horizontal horizontal asymptote, horizontal asymptote, and it is denoted by HA, right? So first off, how can identify the you have applied horizontal asymptote or vertical asymptote? Thus, there is so simple. If I define the horizontal asymptote, right? Define horizontal asymptote. Just discuss with you. So, a horizontal horizontal asymptote is a line y is equals to k that the graph approaches as x moves towards x move towards towards positive or negative infinity, negative infinity, infinity, it tell us that what happened, that I tells you that what happened, what happened to the graph at the left and right, right, left and right. So first of all, before the finding the uh, horizontal asymptote, so this is a basic rule. So that is the called degree comparison. Okay, comparison, com comparison, degree comparison. Okay, to find, how can find the, to find, first of all, to find the HA, okay, compare the, compare the degree of the, degree of the numerator and the denominator. Okay, so what condition is, so so here written as rule, okay, and that side here written condition, and right here horizontal asymptote. Okay, so I have divided in three parts. First, rule 1. Rule 1 says uh, is if the condition is the degree of n is less than degree of n, means that numerator, degree of numerator is less than degree of denominator. Degree of numerator is less than the denominator. Okay, that is that time y is equals to as vertical horizontal asymptote is equals to 0, right? And and if I say, and if I say rule 2 says if degree of numerator is equals to degree of deno denominator, that is represented at dr. So that is the how can find the horizontal asymptote, right? So here, how can find the uh, horizontal asymptote? Sorry so for the uh, disturbance. So we have to discuss about the horizontal asymptote. It is denoted by HA. So horizontal asymptote is a line that y is equals to k, and the graph approaches as x moves to uh, move towards the positive infinity, positive or negative infinity, and he tell us that what happened to the graph at the left or right. So basic rule of the for finding a horizontal asymptote, so we consider the degree comparison, right? So how can the degree comparison, the degree comparison is how can degree comparison, so degree comparison is, first of all, there's a divided into three rules of horizontal asymptote. How can find the horizontal asymptote? So there is a so easy to, first of all, we consider the degree of numerator is less than the degree of denominator. Then directly we say that the horizontal asymptote is equals to 0. And next one is we say the degree of numerator is equal to degree of denominator. That means the leading coefficient, the ratio of the leading coefficient, right? Leading of coefficient of numerator is over leading coefficient of the denominator, right? So the second is a last rule is, if the third rule is says if the degree of numerator is greater than degree of denominator, that time is non-horizontal asymptote. No horizontal, that means no horizontal asymptote defined. Okay, no horizontal asymptote is defined, right? Directly we say that it doesn't define. So basically, as a rule first, I saw the different examples mentioned there. So if I say 2x over x square plus 1, we say the degree of numerator is less than the degree of denominator, right? So here is a degree 1 and here is a degree 2. Obviously we say that the horizontal asymptote is equals to y is equals to 0. You should directly, if you understand and you have a see the rational function and the check the degree of numerator is less than degree of denominator, then we say that the horizontal asymptote is not defined, right? And if you say the rules 2 is says rules according to the rule 2 example, if I say 3x square plus 5 over 2x square plus 1, so you can say that I already told you, if the degree of numerator is equals to degree of denominator, so you find the ratio of the leading coefficient. So here the leading coefficients is 3x square and here is 2x square. 3x square and 2x square, the leading coefficient of numerator and denominator polynomials. So here degree of numerator is equals to degree of denominator. So here the ratio of leading coefficients are 3 over 2. That is called the vertical asymptote here. Okay, that is called vertical asymptote, right? And rule third example is so easy. If I say x cube over function has already defined, so x square plus 1, that is too easy. So directly we say that the function is not horizontal asymptote is not defined. Okay, not defined because uh, not defined. There is a reason is the degree of numerator is greater than degree of denominator, right? So that's time is the no horizontal asymptote, right? No horizontal asymptote. Okay, so I see here the different examples are present over there, and this is the vertical and horizontal asymptote rules. How can find the vertical asymptote and horizontal asymptote? This is too easy, and we have so many examples we have discussed now. So look at here. First question is says, if I say draw 3x minus 1 over x square minus x over 6. How find horizontal and vertical vertical asymptote of the given rational function. This is too easy, right? So this how can find? So first of all, you find the vertical asymptote asymptote is equals to. So how can vertical asymptote we have defined from this here? So first of all, factorize and equate the quadratic polynomial is there in denominator. So x square minus x minus 6 is equals to 0. First I have equate the polynomial and we try to factorize them. X square, and here the leading coefficient 6x square. So first of 2x, and here it is 3x. So x square minus 3x plus 2x minus 6. We take x SCF GCD of x square and x is x. So x minus 3, and take here the GCD of 2x and 6, negative 6 is 2. So x minus 3 is equals to 0. Now what will we do? X minus 3 is the common and x plus 2 is the non-common, equate the 0. So x minus 3 is equals to 0, or x plus 2 is equals to 0. Therefore, x is equals to 3. x is equals to x is equals to 3, or x is equals to negative 2. So these two uh, vertical asymptote, these are vertical asymptote. Asymptote is x belongs to 3 comma minus 2, right? Minus 2 comma 3. Okay, minus 2 comma 3, there's a 2 vertical asymptote. This is 2. Look, this is a vertical asymptote, and then say how can domain find the domain of the domain. So all real values except x is equals to negative 2 or x is equals to 3. So this is the vertical asymptote and domain of the given function. So how can find the vertical asymptote? So you see and you have judged them. Is it possible to find the horizontal asymptote? So horizontal asymptote is 0 because leading coefficient so degree of vertical, we have discussed horizontal asymptote horizontal asymptote. So what horizontal asymptote? So horizontal asymptote is 3x minus 1 fx is equals to x square minus x minus 6. So the degree of numerator is less than degree of denominator, right? So here degree of numerator is less than the degree of denominator. So horizontal HA is equals to y is equals to 0. So this is the vertical asymptote is 0, right? Y is equals to 0. And then uh, how can plot this type of graph? This is important. So you should be the graph is lies between negative 2 to 3, right? Next question is you find vertical asymptote, find the horizontal horizontal asymptote. How can find? So 5x square plus 1 over 3x square minus 4. So you see, degree of numerator is equals to degree of denominator, right? Denominator. So here the ratio of the leading coefficient is y is equals to 5 over 3. This is the horizontal asymptote. Now, this is the horizontal asymptote, and last one is 2x to the power 4 function has already defined minus 3x square plus 5 over x square plus 1. So the horizontal asymptote is not not defined or not defined. Why? Because the leading coefficient degree of degree of numerator is greater than degree of denominator. Okay, so here is y is equals to, so here horizontal asymptote is not defined. Thank you very much. You like my videos, and and you see they're very important topic we have discussed from the living string for USA and all the GCSE, IGCSE, IB board students.